we are going to start out with our vertical shifts, and then we'll do our horizontal shifts. Vertical shifts, that's when we're moving our graphs up and down. We're not changing their size or their shape. We're just moving where they are on the graph. Okay. This is when we've got a number that's added at the end of the function. So our vertical shift would be something like whatever our function is plus some number. So that number at the end is going to tell you whether your graph shifts up or it shifts downward. We'll write down 2 examples that have been shifted and we'll say how they moved. And all the graphs that you're moving are all parent functions that you have on your 12 basic function thing. So if you forget what one looks like, you can look back at that sheet if you're not familiar with it. So if I had y equals x squared plus 2, this is a parabola or a quadratic that is shifted up 2 units because you just have plus 2 added at the end. So you just take your normal parabola and move it up 2 units. Okay. This next one, if I had the square root of x, sorry, not 1, minus 1, that's taking your square root graph, and because the number's on the outside, it's moving it down 1 unit. So numbers on the outside are going to move your graph up or down. So those are our vertical shifts. Now we'll switch to our horizontal. Everything we're doing has a vertical part and a horizontal part. So the vertical shifts were outside of the function or outside of the parentheses. If you'll remember from last year, all of your horizontal shifts, your left and your right ones, were inside of the function or inside of the parentheses. So this would be f of x. We use an h. I don't know why they use an h, but they do. So it's inside of the parentheses. That's going to tell you you're shifting left and right. And remember, these were the weird ones. What's the sign going to be if you're going to the left? It's a plus sign, right? And if you're going to the right, there's going to be a minus sign. Remember, that was always a little bit weird with those. So we'll look at 2 separate ones for this. Let's say we had y equals x minus 3 squared. This is a parabola, right? Because it's an x squared graph. And let's see, which way is this one going to be moving?
Right.
It's going to the right, and it's going to the right 3. So this one, because it was a minus sign and inside the parentheses, we are going right 3. All right, so write down on your paper really quickly which way this moves. Okay. Right. Raise your hand if you think it's going to the left. Raise your hand if you think it's going to the right. Good, y'all are all right. It is going to the left for. I would have you point left or right, but all of your cameras reverse. So like if I'm pointing, this is my left, but doesn't it look like I'm going to the right for y'all? And this is my right. So when y'all are pointing, it looks like you're opposite. That's why I didn't want you to point that way. Okay. This is an absolute value graph. Can y'all show me with your arms the shape of an absolute value graph? It is a V. So this V normally is on the origin. Instead, it's shifted left. Well, I'll go to where it looks like it's left 4 units, and then that's where it is. Okay, so its vertex is now at -4 rather than at the origin. So those are our horizontal and vertical shifts. So that's just sliding up and down and sliding left and right. Now we're going to flip over or do our reflections. We'll go and, oh, these aren't too bad. We're going to go over the y-axis first. Not y, sorry, x. I don't know why I said that. We're going over the x-axis first. These are the kind that you did last year. So it was like a parabola that was right side up. And then at the end, it switched to being upside down. So that is kind of like a vertical flip. It's just going in the vertical direction rather than being up. Now it's going to be down. So it's similar to our vertical shift because the negative is going to be outside of the function. So if it's going over the x-axis, the negative is in front of your function. So y equals -x² is an x² graph that's been flipped over the x-axis. So instead of being here, that's a normal parabola, it is now here. So to make it flip over the x-axis, you just need a negative in the front. We'll do a square root graph. We'll flip that over. Negative square root of x. This is the normal square root of x graph. This is the negative one. I just flip it over the x-axis. Okay. Do y'all remember those kinds of flips? Did you flip over the y-axis at all, or did we just stick to over the x-axis? Did anybody go? You did the y, maybe? We'll see.
Mm-hmm.
Okay. So this is how we're going to go over the y-axis. Doing blue. I wanted this one in blue. Doesn't really matter. Yeah, just go quickly. Over the y-axis is kind of like a horizontal flip. And if we think about our shifts and stuff, our horizontal shift, that's stuff inside of the parentheses. So since we're going over the y-axis and we're kind of flipping it horizontally, our negative needs to be in the parentheses with our x. So if the negative's on the outside, that's going over the y. If it's on the, or over the x, if it's on the inside, it's going over the y-axis. So I'll show you how these two are going to be different for the equations. This is in the parentheses with the x, so that's going to be over the y-axis. It's not sitting in the front of the function. It's inside of the operation with the x. Okay? Same thing with the square root. If it's inside of the square root, that's going to be over the y-axis. I'll show you the square root picture. So that's the original square root graph. Think about if you folded that along your y-axis, think about where it needs to be. What quadrant would it be in if we folded it over the y-axis? You can show me with your fingers. This is quadrant, it goes, in case you forgot, 1, 2, 3, 4. So it's going to be in quadrant 2. I take it, I fold it along the y-axis. That's my reflection along the y-axis graph. So it points it in the other direction. Okay. So inside the parentheses, that's going to be our reflection over the y-axis. So the next thing that we have are our vertical stretch and compressions and our horizontal stretch and compressions. And those are the last two transformations before we put them all together. Just like with the vertical shift, just like with your vertical reflection, your vertical stretch and compress, the number is going to be on the outside. Just like those, the negative sign was on the outside, the plus or minus was on the outside. For vertical stretch or compress, it's coming on the outside of the function. You're going to multiply that number at the beginning. Okay. Does anybody remember the number that A has to be larger than if we want it to be a vertical stretch? Yeah, I see some fingers. It's going to have to be bigger than 1. If it's bigger than 1, it's going to be a stretch. Okay. So if A is bigger than 1, that's going to be a stretch. And if A is between 0 and 1, that's a compression. Because if you multiply something by a number that's bigger than 1, isn't it going to grow? Like if you multiplied something by 1.5 or by 2 or by 3, it's going to get bigger. But if you multiply something, someone give me a number between 0 and 1.
0.5.
0.5. If you multiply something times 0.5, it's going to cut in half. Or 1/4, it's going to cut into a fourth of it. So that is why it would be a compression. It's going to make it smaller in stature than the vertical stretch that's going to make it taller, and it's actually going to be skinnier. So if you take your hands together right now, we're going to do a vertical stretch. So take your hands. Leave your bottom hand there, but you're going to pretend you have a parabola, and you're taking your parabola and you're pulling it up. That parabola is going to get tall and skinny, right? Kind of like if you had Play-Doh or something. But if you got your parabola and you are pushing it down, the sides of it are going to go out to the sides, right? So a vertical stretch is going to make it tall and skinny. A vertical compression is going to squeeze it out to the sides. Okay? Does that kind of make a little bit of sense? Of vertical stretch, tall, compression, wide. All right, so we'll look at two just functions and see if y'all can tell me if it's a stretch or compression. So if I have y equals 2x squared, we have that 2 in the front. Is that going to be a stretch or compress?
Stretch.
It's a stretch, and it's going to stretch by a factor of 2. So that's a vertical stretch by a factor of 2. So all of the numbers that you had, all of your y values are now multiplied by 2. So they've stretched by a factor of 2. Okay, our next one, we have 1/3 times the square root of x. Is this a stretch or compression?
Compression.
This is a compression, and this will be a compression by a factor of 3. So it got 3 times smaller than it was originally because it's 1/3 of the size. So a vertical compression by a factor of 3. So if you're 1/3 the size, you've been compressed by a factor of 3. You've divided it into thirds. Okay. So for vertical stretch or compress, our numbers are on the outside. Where do you think the number is going to be for horizontal, just based on what we've done so far? Where have all of the horizontal things been? This is a horizontal one. This is a horizontal one. It's going to be inside the parentheses. So if you've got a number multiplied by x inside the parentheses, that's our horizontal stretch or compression. Oops, we need a B right there. Okay. So what we're going to think about is we can go back to our hands and doing horizontal stretches and compressions. If I take my graph, like a parabola or something, and I stretch it horizontally, stretching it horizontally is going to spread it out, right? So if you take your graph of parabola and we're stretching it horizontally, that's going to be way spread out, right? If I took it and I horizontally compressed it, that's smushing it together, which is going to make it taller. So it's a little bit different, and what you need to think about is like a vertical stretch does the same thing as a horizontal compression. Can y'all see my hands? Like a vertical stretch stretches it up. A horizontal compression pushes it in, and those two things do the same thing. So the numbers need to match. So when we said a vertical stretch, A was bigger than 1. For this, when B is bigger than 1, it's not going to be a stretch, it's going to be a compression. So they're going to reverse. When B is between 0 and 1, this will be a horizontal stretch. Okay. So if I had y equals 2x squared, is this going to be a horizontal compression or a horizontal stretch? Did I write the wrong numbers in there? Yeah, compression, sorry. Yeah, horizontal compression. So B is bigger than 1, so that is a horizontal compression. Which matches with the same thing that a vertical stretch does. Horizontal compression goes that way. And it's a horizontal compression, and it's going to shrink it by a factor of 2. It's going to be half the size it was before. And one more. Let's go with 1/3 x cubed. Is this a horizontal stretch or compression? Horizontal? Horizontal? It'll be a horizontal stretch, right? So really all you need to know is if the number is inside of the parentheses or inside of the operation with the x, that's going to be horizontal. If it's outside, that's going to be vertical. Okay. So we're going to put it all together, all in one, so that you could just look at that and see if you have numbers that are in those positions, you'll know that's moving it up and down, that's moving it left and right. Okay, that's going to flip it over this axis. If it's right here, it's going to flip it over this other axis. Okay. So this is all together, all of the things. We could have a plus or a minus to start us off. We could have a number multiplied. Have parentheses, and inside those parentheses, we could have a plus or a minus. We could have a number multiplied. And we could have this. So those are all 6 of the things. We're going to write down what all of those things do to a graph so that when you see a function, you can just refer back to this if you need to. Then I'll have y'all practice one before you work. Let's go from the things that we did at the beginning. What does the plus K do, or a number added at the end? What's a number do added at the end? Shifts it.
It determines if it goes up or down.
Up or down. So this K value is going up or down. That's just a number at the end. Okay. If it's inside the parentheses with the X and it's got a plus or a minus, those
Goes
are
left to right.
left and right. Good. Left is a plus, minus is the right. If you have a minus sign in the very front of your function, that's going to flip over which axis? X. So this is going over the X axis. If you have a negative inside, that's going to go over the which axis? The Y. Okay. And then if a number is multiplied in the front, that is a vertical stretch or a vertical compression. If it's multiplied on the inside, that's our horizontal stretch or our horizontal compression. So all the things outside of the parentheses have to do with going up or down, stretching up or down, flipping up and down. Everything on the inside, left and right, stretching left and right, flipping left and right. So all the left and rights are on the inside, all the up and downs are on the outside. Okay. All right, so I'm going to write one down, and I want y'all to tell me, well, I want you to think about it first, and then we'll go through what's happening to this graph. Okay, are you ready? You're born ready. I can feel it. F of x equals 1/2 times the square root of negative x plus 2 minus 4. Why not?
So, like, do we just write out to the side what it's doing? Like, if it's a vertical or...
Yeah, I would just write just like this. I could write it like that and just do a little arrow. This means I'm doing this. 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 So you've got 4 transformations. So write down what those 4 are, and I'm going to call people to help me out, to give me one at a time. So I'm going to call on 4 people. So make sure you're ready and you know what all 4 of those things do. Oh, I know. I just didn't move. I was just being still. All right, we ready almost? You know what all 4 of those things do? Let's see, who have I not called on today? Let's go with Aaron. Tell me one thing that's happening from this graph.
The 4 on the outside tells you that it's going to go up.
Down?
Up.
Down? Up and down, you can
-4.
Yeah.
I put +4 on my paper.
Oh, on your page? Okay.
Minus, then down.
Okay, good. That's fine. All right. All right, so down the 4. Okay. Lauren, over the y-axis means like that you would fold the graph and it would flip from one side to the other side. Are you talking about the picture or where it shows up in the equation?
Like where it shows up in the equation.
Okay, if it's inside of the operation, so like underneath the square root sign, in an absolute value sign, in parentheses before you square something, that would be over the y-axis. X-axis is in the very, very front. Okay. All right. Let's see. Let's go with Dion. Tell me one other thing on this graph that's happening.
We
We got 3 things left.
Yep. Oh wait. In the middle of the
Yeah.
the negative x, the in parentheses thing,
Mm-hmm.
it's gonna go to the right. I mean to the left.
How many?
How many?
Mm-hmm.
1, 2.
Yeah, 2. That's why it has a 2 there. So we're going to the left 2. So left 2. Okay. All right. Let's see. Anybody? How about Hannah? You want to give it a try? One of the last 2?
I'm gonna be honest, I only had the 2 that they just did. So
Okay, well, let's look at the last 2. We've either got a negative on the inside or a 1/2 on the outside. So you can think, I would probably go with the negative one. If the negative's on the inside, what does it mean?
it's over the y-axis.
So there you go. Flips over the y-axis. Anytime you get stuck, if you look up here, you think, was that inside or outside? Okay. Was this number inside or outside? All right, what does that mean? So we're down to our last one. It's a 1/2 in the very, very front. Who have I not called on today? What about Jade today? Awesome. One half is in the very front.
I can just answer if you want to.
Oh, wait, she's almost got it. There you go. Vertical compression. She was typing it, I could tell. But thank you, Spencer. Vertical compression in the very front. So a number in the front, that's a vertical stretch or compression. Since it's less than 1, that is our vertical compression. Okay. So you would move it down 2, shift it left 2, flip it over the y-axis. So it'd be going backwards. And then it would have a vertical compression. So it would be a little squatty bodied square root function shifted in those positions. So this will tell you where your vertex will be on your graph for all of those. Okay, so that's how you go through and think about them. If you're doing your work today and you start missing a couple in a row and you can't figure out what it is, don't just keep missing problems in a row. Like stop and ask me and say, hey, I'm on this problem. I can't seem to get it, so that you know what you're doing. Okay. You should have enough time to finish almost all of them if you just get started and working. You do not have to write anything down and turn it in. You just have to do the CUDA problems for this lesson since they're just identifying graphs. Okay. So no scratch work to turn in, just work the CUDA problems, but stay on right now and start working those problems now. And if you're playing video games or watching TV, I can tell, and that is not a good look for you.
Fuck you, bitch.
Do you want me to mute you, Dion, or are you having trouble? There you go. I got you. Well, maybe. Work. Nah, I will. I guess if you want to turn in your notes so you have them in there.
My camera might not be on because I'm on my phone, so it'll not be on.
Miss Roselle,
Yes.
my CUDA link for my phone isn't working. I don't know if anybody else is having that problem, but as I'm trying to open it, it sends me to another page. It's like 504 disconnected or something like that.
Just try to search, like Google search CUDA student and see if you can do it that way.
Okay, gotcha.
Yeah, on number 24, The stuff in the bottom with the X is like in the parentheses. So in the bottom part, that -3 is like a left and right shift. And the 3 on the top, it's like a number multiplied in the front. So that's an A value. Okay. There's still 9 people in here that have not opened the assignment. So you've had like about 10 minutes so far to work, and you haven't even taken the time to log in to start to open the assignment. So when I give you time to work, use it so you can ask questions when I'm sitting right here. Okay?
So what does it look like if it's a horizontal stretch or compression? Because only seeing vertical stretches.
So if it's a horizontal stretch, if you see my hands, a horizontal stretch is like pulling it from side to side, which is kind of making it more like shorter and a little bit fatter. But if it's a horizontal compression, it's making them taller and skinnier. So horizontal compression and a vertical stretch have similar, the picture looks the same. Okay.
What was that? 1, 2, 5. Oh, I stopped the recording.